Okay, so I chose to do my project on David Hubel. He was the Nobel Prize winner of 1981. Okay, so a little bit about him. On November 27th, 1926, David Henry Hubel was born in Windsor, which is a city located in Ontario, Canada. He was born into a highly educated family in which he was exposed early to the concept of medicine through his father, who was a physician. This exposure to science at a young age influenced him to gain a fascination with neuroscience and the function of the brain. This ultimately led to him attending McGill University in Montreal, Quebec, in which he would end up earning his bachelor's degree in physiology in the year 1948. Following his studies at McGill University, he then went on to pursue a PhD in physiology at Harvard Medical School, earning his doctorate in 1954. After earning the doctorate, he spent the majority of his career conducting research and teaching courses related to the field of neuroscience. Beginning in the 60s into the 70s, he worked on his groundbreaking research regarding the development of the visual system, along with his partner in research, Thorsten Wiesel. This research would go on to earn him and Wiesel a Nobel Prize in Physiology and Medicine in the year 1981. Later in life, following his long career in research and teaching at Harvard, he lived more of a quiet and private life up until his eventual passing on September 22nd, 2013, at the age of 86 years old. Okay, so the Nobel Prize-worthy work that Hubel conducted alongside his partner Thorsten involved developing a greater understanding of the function of visual processing. The experiments involved the use of cats and primates as the subjects, in which they underwent a craniotomy to expose the visual cortex of these animals, which is basically the area in the occipital lobe that is known to be responsible for visual processing. Electrodes were then inserted into the primary visual cortex in order to measure changes in activity. Measure changes in activity when presented with a particular stimulus. The stimulus presented to the animal subjects were obviously visual, but differed in multiple ways. Drawings of patterns of thin lines were presented, but the stimuli could differ in terms of angle in which the line was drawn, if the lines or patterns were moving or not, or if the systematic patterns were light or dark. Different types of stimuli were grouped together based on the neuronal response they elicited, and which was recorded by the electrodes that were inserted into the brain. So from these experiments, Hubel and Wiesel found a few things. One major finding was that the neurons within the primary visual cortex and the occipital lobe respond with differences in electrical activity to the different types of stimuli presented. Another discovery was that through inserting electrodes deep into the visual cortex, they were able to find that neurons within the cortex were aligned in a columnar manner, and that neurons in the same column respond to the same type of stimulus. Through testing the animal subjects throughout the development, it was also found that there's a strong degree of neuroplasticity within the visual cortex, especially earlier on in life. They tested this through temporarily occluding the vision in one of the eyes for a period of time, and found that when occluded earlier on in life, there was a weaker neuronal response to stimuli in comparison to being occluded for a period of time later on in the life of the animal subject. This would then suggest that neuronal connections within the primary visual cortex are strengthened to a higher degree in response to visual input in the earlier stages of development. So the discoveries from this experiment have had a lasting impact. For example, with the discovery of the primary visual cortex displaying neuroplasticity in response to visual sensory input, it opened the door to future research to expand beyond neuroplasticity in the visual cortex. The discovery of the fact that the visual cortex has a tendency to display greater neuroplasticity in earlier development placed a large emphasis on the significance of early exposure to stimuli to the brain for neuronal development. With this emphasis placed on early development, new clinical approaches to sensory deficits emerged in which the importance of early intervention being more likely to restore normal sensory function was then stressed. In addition, the approach of using electrodes in order to attempt to map out the visual cortex was heavily influential towards the methods used in future research, focusing in on other areas of the brain and the response elicited by the other sensory stimuli.